Hey guys, Lissandro here, and I'm gonna be doing another blog, and I guess it's kind of a combination of um, whiteboard display and blog and everything. So what I wanted to cover is an interesting concept that I came across. I get a variety of different scientific ideas, things I wanna create, but unfortunately I don't have nor the time nor the resources to do it, which is why I'm gathering, doing like crowdfunding for set of fundings for my lab. So anyway, let me go over to the whiteboard over here.
Okay, so basically the idea is this. As you all know, we're surrounded by heat. Okay, you all know what heat is. Whenever you have, like, let's say, any hot food or anything, anything, whatever you're cooking or so, um, it radiates heat, whether it's through infrared convection or direct thermal contact. It's heat, and the thing is that heat is everywhere, all your surroundings and all. And the thing is that there is no in physics there is no way you can't have heat at some point. Even the coldest temperatures, like for example 30 degrees Fahrenheit, um, it has some level of heat. The thing is that it's the lack of heat, and you can't have 0 Kelvin. You can't have 0 Kelvin because 0 Kelvin is at the point which there is no heat within within the system. There's absolutely no heat here. And if you know ideal gas laws, it's relevant to pressure, and it's at the point where you have zero pressure, which is whether you use pascals, atmospheres, or bar or millibar, uh, uh, etc. It's at the point where there's absolutely no pressure. Now, my thought was this: how about getting one of these guys, and pretty much just applying electricity. Now, the thing about these guys, if y'all don't know from some of my previous videos that I showed, is that these guys, if you apply an electrical current, okay, you apply an electrical current, positive and a negative terminal, and the thing is that you apply an electrical current, and what you get is that on one side you get it heating up. On the other side, what happens is that it cools down, and pretty much what you get is a thermal pump. Now, my concept is this: how about, like, pretty much creating a system in which you suck up a lot of the heat from the environment. Um, a lot of the heat from the environment, ambient heat, the heat from the air, okay, and using it to cook your food, whatever food you choose and all, okay. And the idea sounds nice and all, and and remember, this is just a concept. Now, the problem with this is that this little uh, this little system it has some issues with inefficiency. I haven't checked the calculations in regard to this, but let me just give you an example of one of the problems that you pretty much run into. Okay, one of the problems you run into is the mass of the food that you're cooking. Okay, depending on how much mass is how much energy you absorb, how much heat you absorb. And the thing about this is that um, the larger mass the larger amount of mass that you have in your food, the more energy it's going to take to cook that food. That's one. The other thing is distribution of heat within the food and all. And the thing is that it's not going to take the same temperature as if you were had something small. Okay, you have to consider that because eh, if you remember the formula for heat is the amount of the amount of heat, which is delta U, is equal to the quantity of mass times the thermal coefficient times delta T, which is the difference in temperature. So if you let's say you have a specific amount you have a specific amount of mass. In order to successfully cook it, you need a certain amount uh, of thermal energy to cook it efficiently, and plus more for thermal dissipation of your food that's probably gonna escape. You're gonna need a huge temperature difference because remember some foods uh, you have to cook it at really high temperatures because and especially if you're dealing with pork because you have to cook at high temperatures if you want to like get rid of like little parasites and other shit and that's pretty much what the case is with this. It's not that's one of the issues and all. Okay, the other issue you run into is is this. Let's say you have this device, and let's say you have one side hot and the other one is cold. Okay, remember you have condensation issues because what will happen is that uh, one thing you have to keep in mind is that the more uh, the more hotter it is outside, the the more the more reservoir of heat that you have, the more a higher source of heat that you have. But the problem is this: the reason why the Earth's atmosphere is able to retain heat is because our percentage of water, our percentage of water, okay, how much percentage is in the atmosphere, and the reason why is because of thermal capacity, your heat capacity. How much heat can each of these water droplets absorb to retain heat? Because what would happen otherwise if we didn't have this water in the atmosphere? What would happen is we would have an atmospheric uh, escape of heat. That's when heat dissipates directly into the atmosphere and directly out into space. It doesn't nothing retains it because air does not retain heat as efficiently as water. Air has a lower heat capacity than water. Okay, so the deal is it'll condensate here, especially since this device has area. Okay, since this device has area, it'll condensate, and because of the fact that it'll condensate, the heat's not gonna go directly to the device. What will happen is it'll go have to pass through the water. The water pretty much absorbs the heat, and then what happens is that you make it more difficult for heat to transfer over. Because remember one thing about this, um, the heat. The heat that you get here is um, the heat from your power supply, your electrical power supply, plus the heat from your atmosphere. Uh, okay, the heat from your atmosphere. Okay, so if you're not getting sufficient heat, then a lot of the heat that you're using here would be mostly this. And sometimes it may not be efficient enough to cook the food. Because the thing is, especially if you're cooking something cold, what will happen is that it'll pretty much act like a heat sink. And if you know heat sinks, is that heat sinks tend to suck up the heat. Of course, there's a difference. Heat sinks absorb the heat and dissipate the heat. While this thing, especially if it has a lot of mass, it's going to absorb a lot of the incoming heat. And the thing about this is that it's going to be absorbing the heat, and the outside air is going to be stealing heat from it. So it's not going to be an efficient system. Apart from that, the bottom part is likely to freeze because these devices pretty much have the capacity to freeze water. Okay, so it's basically like this video from Thunderfoot that I watched, and he was referencing in regard to some guy that had created some solar panel and a Peltier unit, which is this device, to condensate water. The idea is nice and all, but it's not cost effective, and it's not efficient because it takes a really long time to condensate a substantial amount of water. The same applies here. Okay, this may be probably good to cook small food or anything like a small snack, something small. Probably heat up a sandwich, but that's about it. But as far as it cooking food efficiently, Uh, you're better off cooking with an electric stove, if that's the case. But the concept's interesting, and there might be some improvements later on and all. Okay, and what are and in reality, you want to know what these are. These Peltier units, what it is that in the inside has a lot of diodes. It has a lot of it has an array of diodes in zigzag, arranged orderly, and these diodes are made of bismuth telluride. Bismuth telluride. This is an alloy. Uh, you may um, you may remember bismuth. The name bismuth may sound familiar because it, in reality, it comes. Bismuth is used in the synthesization with synthesizing a common over the counter medicine that you pretty much take whenever you have diarrhea or stomach problem. And yes, it's Pepto Bismol. Pepto Bismol. Okay, and yeah, you that's what they use. It's a peptide of it's a peptide of in which they include the bismuth element. They synthesize a compound in which they use to help control like indigestion problems and other stuff. It's a little bit more complicated than that. But the interesting thing about this is that this metal, bismuth, this metal, is more heavier than lead. Okay, it's not as toxic as lead. Okay, but it's heavier, and the thing is that it's slightly radioactive. Okay, yes, it's slightly radioactive. Okay, let me see if I can let me see if I can draw this stupid thing. It's slightly radioactive. I can't draw this shit right. Uh, but anyway, it it's slightly radioactive. It's not that radioactive at all, but it is slightly. In reality, we radiate we radiate more radiation than what this does because of the carbon isotopes and the potassium 40 isotopes found in our naturally found in our body. This is found in nature. So just a little fact: we are radioactive. Just in case y'all didn't know. So that's a little fact there. So pretty much this alloy is um, what's included in these Peltier units, and it has this unique property to heat on one side and cool on the other. It, it's pretty much a thermal pump. But anyway, that's pretty much all I wanted to share with y'all for the time being. Thank you for watching. Please like and subscribe, and I'll catch you guys next time. Bye.